So good evening everyone. This is a problem solving session 3 for the course Fundamentals of Spectroscopy. So firstly, in the first lecture, it was about the correspondence between the linear and the rotational motion. So basically in this lecture, we know that the microwave region so here we will talk about the microwave region. Why? Because the rotational spectroscopy, we know it is in the microwave region. Just a second. And for the rotational spectroscopy, we deal with the microwave region. And in the microwave region, what is the frequency range? It is generally 1000 megahertz to the 300,000 megahertz. 300,000 megahertz. And we know that 1 megahertz, it corresponds to 10 raised to the 6 hertz. So now in the rotational motion, now we know it is in the microwave region and the frequency is 1000 megahertz to 300,000 megahertz. And also in the previous session, we discussed that the energy of the vibrational, electronic and rotational. So which one was the larger? For that, among all these three, the energy of the electronic was larger than the vibrational and then to the rotational. As we know, if we just draw some energy level diagrams, so this one is the electronic energy level. So within this E energy level, there will be vibrational levels, and in between this vibration level, there will be different rotational levels. So the energy of the vibration levels will be higher than the rotational level, and electronic will be much more higher than the vibration as well as the rotational levels. So now we will discuss some of the relations. We know that omega equals to v by r, where what was omega? Omega was your angular velocity, and v was your linear velocity. So this relation was there. First, w is v by r. Then we also know that frequency is equals to that the frequency is equals to v by 2 pi r. This was one relation. And from here we can also know what was the relation between the frequency and the angular velocity. That angular velocity is equals to 2 pi mu. And if we substitute the value frequency from the above equation, so it will be 2 pi v by 2 pi r. So here 2 pi will be cancelled out. So finally omega will be equal to v by r. So this is the relation between the angular velocity and the linear velocity. That is, angular velocity is linear velocity divided by r. Now another term we will use is the linear momentum and the angular momentum. As we know, linear momentum we denote by p, and p is mv. And for the angular momentum, we denote by L. And angular momentum is equals to the cross product of r into p. Also, if we just see the term of angular momentum and what is the relation between the angular momentum and the moment of inertia. So we know that angular momentum is equals to I into omega. That is, angular momentum is equals to moment of inertia into the angular velocity. So L is your angular momentum, I is your moment of inertia. So now we know the relation between the angular velocity and the angular momentum and moment of inertia, that L is equals to I into omega. Now this was some terms that we use like linear momentum, angular momentum, linear velocity and angular velocity. Now we also know that if we just compare that moment of inertia, what is the value of moment of inertia? In the sessions it was mentioned that I is equals to mr square. How we no, just a second. As we know that L is cross product of R into P. So from here we know that what is the value of P? P is the linear momentum and linear momentum is given by mv. So it will be mvr. L is equals to mvr. Also from the above we know that what is angular velocity? It is equals to linear velocity by r. So we can substitute the value of v here, that is L is equals to m omega r by r. That is L is equals to m omega r square. We can simply write this, and we know that L is equals to I omega. How? Because as I is equals to mr square. So here we can simply remember these formulas. Sorry. So let's continue here. Now it is clear what is the relationship between the linear velocity, angular velocity, and what is the relation between the moment of inertia with the momentum. Then there were some more terms, like if we just discuss about the so what was the correspondence between these? So firstly, if we just see about the position, if we just see about the position, then for the linear case, we know represent by x, while for the angular motion we use the term theta. So now if we just compare about the velocity, maybe I will write in the next page. So first, if we just look at the distance, it will be x for the linear case, while for the angular we use theta. Now velocity. Velocity, we know it is dx by dt, and from here we used angular velocity, that is v by r. Momentum is equals to mass into velocity mv. Here we use L is equals to I omega. Similarly, kinetic energy. Here we use kinetic energy is half mv square, or we can say p square by 2m. And for the angular we use half I omega square, or we can say L square by 2y. So this all we have to remember. And also for the mass we use m for the linear, and here we use the term moment of inertia. Now we'll just erase these things. Is it clear to this? One more thing I will discuss here, as we know that here we talk about the angular momentum, and angular momentum is quantized. What does it mean? It means h cut is h by 2 pi. So for the quantized angular momentum condition, it requires that L is equals to J into h cap. And what is J? J is your the rotational quantum number. Rotational quantum number. So we can write L is equals to under root J dot J h cut, and we know that energy is equals to L square upon 2I. So we just substitute the value of L square here. So L is J dot J h cut whole square upon 2I. So it will be h cut square upon 2I e j plus 1. And what is h cut? You know, h cut is h by 2 pi. So we substitute the value here. So it will be h square upon 8 pi square I j plus 1. And this is the value of energy. The energy is equals to the h square by 8 pi square I. That is j plus 1. Is it clear? So the same expression we will also get from the Schrodinger equation. Now let's solve some questions accordingly. Also, before going to that, I will just discuss one more things. So like for the diatomic rigid rotor and for the selection of degeneration, they have discussed in the lecture 2, I think 2, 3, 4 lectures were all about this. And what is selection rule? According to selection rule, delta j is equals to plus minus 1. This was your selection rule. And what about the degeneracy? It is j plus 1. Degeneracy, we know it is j plus 1. 2j plus 1. That is j. It was gj 2j plus 1. This was the degeneracy. So now we will solve some questions. So for the first question, Hi and Di are made to undergo the same transition from G0 to G1. The light frequency causing the transition for Hi equals mu. Approximately, which frequency would you expect to induce the same transition in Di? It's 2 mu, under root 2 mu, mu by 2, or mu by under root 2. So what will the answer for this? We know that energy, I will just write here maybe. We know the energy is equals to h mu. H is the Planck's constant and mu is the frequency. And we also know that the delta is equals to 2b. What is the value of b rotational constant? It is h square upon 8 pi square I. This we already know. And as we know, I is equals to mu r square. And delta E is inversely proportional to I. And I is directly proportional to mu. So it is also inversely proportional to mu. E is inversely proportional to mu. So we can simply write in terms of energy that E of Di divided by E of Hi will be equal to mu of Hi divided by mu of Di. So it will be equal to 1 by 2. Now we know that mu is equals to del E by H. So if we just like del E is of di, the energy is of di upon H. So we know di is del EHI divided by 2, that is upon H, which will be equal to H mu by 2H. That means H will cancel out mu by 2. The correct answer will be option C. So the answer will be option C. This mu by 2. Now in the next question, in the hydrogen molecule, when hydrogen is replaced by deuterium, what will happen to the rotational constant B? So now what they have done is that the hydrogen is replaced by the deuterium. Deuterium is an isotope of hydrogen. So we know that the reduced mass of deuterium will be more than the reduced mass of hydrogen, and we know that B is inversely proportional to 1 by mu. So if reduced mass will increase, then B will decrease. So the answer will be option C. It will decrease. So what will happen to the rotational constant? It will decrease. Next question. The moment of inertia of CO molecule is 1.46 into 10 raised to minus 46 kg meter square. Calculate the energy in electron volt and the angular velocity in the second lowest rotational energy level of the CO molecule, J equals to 1. So for here, we know that now we have to calculate the energy. Energy we have to calculate. So we know that energy is equals to, so E of any J level, it will be equal to H square upon 8 pi square I J plus 1. And now they're asking for the second lowest rotational energy level, and so it will be equal to J will be equal to 1. Second lowest means J will be equal to 1. So for E, J equals to 1, it will be H square upon 8 pi square I, and J is 1 and 1 plus 1. So it will be H square upon 8 pi square I into 2. So it will be H square upon 4 pi square I. And what is the value of H? H is 6.626 into 10 raised to minus 34 whole square divided by 4 into 3.14 whole square into I. And what is the value of I? It is given 1.46 into 10 raised to power minus 46 kg meter square. So after solving it, what will we get? We will get 7.61 into 10 raised to power minus 23 joules. But in the question it is mentioned that we have to calculate the energy in electron volt. So for the electron volt, we have to divide by 1.6 into 10 raised to power minus 19. So after that, what will the answer? It will be 4.75 into 10 raised to power minus 4 electron volt. This will be the value. Now it is clear. So we have calculated the energy. Now we have to calculate the value of angular velocity. Angular velocity. So for angular velocity, we know that it will be equal to to E by I. How? We know that energy is equals to half I omega square. And from here we have calculated the angular velocity. Now just substitute the values. So it will be 2 into what was energy? Energy was 4.75 into 10 raised to minus 4 electron volt. And moment of inertia was given to be 1.46 into 10 raised to minus 46 kg meter square. So after solving it, we can calculate it will be 10.2 into 10 raised to 11 radian per second. So this is the value of the angular velocity. Is it clear? Now we will just see the next question, that is j equal to 0 to j equals to 1. The absorption in the CU occurs at a frequency of 1.153 into 10 raised to 11 cycles per second. Calculate the moment of inertia and internuclear separation of CO. So now we will solve this question, that is from j equals to 0 to j equals to 1, the absorption line in the carbonate occurs in the CO. In the CO, it occurs at a frequency of 1.153 into 10 raised to 11 cycles per second. Calculate the moment of inertia and internuclear separation of CO, of carbon monoxide. So basically here we have to calculate the value of I and the internuclear separation R. And we have been given as a frequency is given, that is 1.153 into 10 raised to 11 cycles per second. So how we will calculate it? So as we know, the energy separation between j equals to 1 to j equals to 0 to j equals to 1, it is given by delta E is equal to delta E of j equals to 1 minus delta E of j equals to 0, which will equal to h square upon 8 pi square. So which will equal to energy equals to h square upon 4 pi square I. And we know that energy is equals to h mu. So from frequency it will equal delta E by h. Now we know that I will just erase it first. as as frequency is equal to delta E by h. Now we know that delta E is h by 4 pi square I h How? Because we know that delta E was h square upon 4 pi square I. So we will substitute the value of E, and here it is h upon 4 pi square I, because h would cancel out. Now let's substitute the values. We know that it will be equal to 6.626 into 10 raised to minus 34, 4 into pi, that is 3.1 whole square, into I. And what was frequency? It was 1.153 into 10 raised to power 11 cycles per second. So from here we can calculate that the moment of inertia will be equal to 1.46 into 10 raised to power minus 39 gram centimeter square. Now I is given. Now we have to calculate the value of R, and we know that I is equal to mu R square. From here R square will be I by mu. So R will be under root of I by mu. And we know what's the moment of value of moment of inertia. It's 1.46 to 10 raised to minus 39. And what is reduced mass? So for this we have to calculate the value of mu. And from here, so we can calculate the value of mu. For the mu of carbon, it will be equal to mu of C multiplied by mu of O divided by mu reduced mass of C plus reduced mass of oxygen. So we know that reduced mass of carbon, it is 12 into 16 divided by 12 plus 16. So we have to multiply or get the number. So then it will be 12 into 16 divided by 28 into the Avogadro number. So we know Avogadro number is 6.022 into 10 raised to the 23. So just multiply it and then you will get value 1.14 into 10 raised to the minus 23 gram. The value of reduced mass. So now put this value here, that I will be equal to 1.46 into 10 raised to the minus 39, and reduced mass we calculate to be 1.14 into 10 raised to the minus 23. So after solving it, it will be 1.13 into 10 raised to the minus 8 centimeter, or you can simply say 1.13 angstrom. Is it clear? Is it? Then we'll solve some next question. The OH radical has a moment of inertia So now the value of OH. So for the value of OH minus, value for OH minus, it is moment of inertia is given to be 1.48 into 10 raised to minus 40 gram centimeter square. Now we have to calculate the internuclear distance. Also calculate for J equals to 5 its angular momentum and the angular velocity. So we have to calculate, and also we have to determine the energy. It's also we have to calculate. Now we know that reduced mass, firstly we have to calculate for the OH, and for it will be equal to 1 into 16 divided by 1 plus 16 into Avogadro number, that is 6.023 into 10 raised to 23 divided by 6.023 into 10 raised to 23 whole square. So it will be 16 divided by 17 into 6.023 into 10 raised to 23. So it will be 1.56 into 10 raised to minus 24 gram. So this will only reduce mass. Now we know that R is equals to I by mu by, because I equals to mu R square. From here we can calculate the value of R. So R will be under root of moment of inertia by mu. The moment of inertia is given 1.48 into 10 raised to power minus 40 gram centimeter square. and mu is 1.56 into 10 raised to the minus 24 gram. So from here, after solving, we'll get 0.97 into 10 raised to the minus 8 centimeter, which will be equal to 0.97 angstrom. So now you have calculated the moment of inertia value. Now we have to calculate internuclear distance also we have calculate. Now for value of j equals to 5, like j is equals to 5, we have to calculate the value of angular momentum. So L, we know that it is equals to under root j by j plus 1 h by 2 pi. So set the value of j. Now j is 5, so L will be under root 5 plus 1 h by 2 pi. So it will be 5 into 6, that's 30 h by 2 pi. So it will be 30 by h by 2 pi. So in root 30 into 6.626 into 10 raised to minus 34 divided by 2 into 3.14, it will be 5.77 into 10 raised to minus 27 of second. So this will be value of L. Now we have to calculate the angular velocity as well. Angular velocity is L by I. So L, we know it's 5.77 into 10 raised to minus 27. Moment of inertia was given to be 1.48 into 10 raised to minus 40. And from here the value of angular velocity will come out to be 3.90 into 10 raised to 13 per second. So now angular velocity is done. Now we have to determine the energy. So for the energy, let me just take extra slide. So for this, now we have to calculate the energy value. Okay. So for that we know that wave number is equals to 2b j plus 1 and j is your the lower state value. That is from j equal to 6 to j equals to 5. So mu will be equal to 2p 5 plus 1, that is 12b. And b, we know b is 12h upon 8 pi square IC. Substitute the value 12 into 6.626 into 10 raised to the minus 34 divided by 8 into 3.1 whole square. And what was the value of I? I was 1.48 into 10 raised to the minus 40 and C 3 into 10 raised to the 10. So after solving, it will be 227 centimeter inverse. Now we know that what is the relation between energy and frequency is equals to mu hc, that is 227 into 6.626 into 10 raised to minus 27 into 3 into 10 raised to 10. So it will be 4.50 into 10 raised to minus 14 per molecule. So this is the value of energy. Now we will solve some next question. The microwave spectrum of a rigid atom molecule shows first three lines at 2.65682, 5.31364 and 7.97046. What will be the rotational constant of this molecule? So we have to calculate the rotational constant. Now for the first line, it is 2.65682 centimeter inverse. For the second line, it is 5.31364 centimeter inverse, and for third line it is 7.97046 centimeter inverse. So we know that the spacing is separation is 2b, so it will be 5.31364 minus 2.6568, because you know the separation between the two lines is conjugate line is equal to 2b. So we know that if we just subtract these two second and first line, we will get 2b. So it will be 2b will equal to 2.65682. So from here you can calculate the value of b. It will be 2.65682 divided by 2, that will come to be 1.32841 centimeter inverse. Is it clear? So here the answer will be option C, 1.32841. Now next question, calculate the reduced mass and moment of inertia of 40 nitrogen 16 O. So bond length is given to be 1.5 picometer. So we have calculated the reduced mass and moment of inertia. We know that I is equals to mu r square. So for calculating moment of inertia, we should know about the mu, reduced mass. So we know that reduced mass is equals to the, for the NO, it will be mass of nitrogen into mass of oxygen divided by mass of nitrogen plus mass of oxygen multiplied by Avogadro number and Avogadro number whole square. So what is the mass of nitrogen? It is 14 into 16 divided by 14 plus 16 into Avogadro number, that 6.023 into 10 raised to 23 divided by 6.023 into 10 raised to 23 whole square. So it will be so after this, after solving, the value will be 1.240 into 10 raised to power minus 26 kg. This will value of reduced mass. Now we know that I is equals to mu r square, and we have to calculate moment of inertia. So let's substitute the value of reduced mass. It is 1.240 into 10 raised to minus 26. And what is R? And just a second. Just a second. So now the value of I was 1.240 into 10 raised to minus 26 kg. So as I is equals to mu r square, so we have to calculate the value of moment of inertia. So this was the value of mu. Just a second. It is not getting erased. So mu was 1.240 into 10 raised to minus 26 kg. So substitute the value here. I is equals to 1.240 into 10 raised to minus 26, and R was given 1.15 picometer. Picometer to meter we convert, it will be 10 minus 12 meter. So the answer will be 1.640 into 10 raised to minus 46 kg meters. They leave the answer. Is it clear?
Yes, ma'am.
So now we will solve some questions again. This was, I think, your assignment questions. So what will be the relation between the linear velocity and the angular velocity? So linear velocity is v and angular velocity is w. So what will be the relation out of this? So what is the relation between linear velocity and angular velocity? We already discussed that angular velocity denoted by w, it is equals to v by r. Yeah, w is your angular velocity and v is your linear velocity. Now next question. Just a sec. I don't know what is going on. Now for the next question. Select the correct match. Mass equals to linear motion, moment of inertia. Moment of inertia is linear motion, mass rotational motion. P equals to mv, L equals to I W. So what will be the correct answer for this? Rashmi? We know that linear momentum is equals
जी
to
miss.
mv. Linear momentum is equals to mv. P equals to mv. Linear, for a linear momentum, it is not by p. It is equal to mass into velocity. And for the angular momentum, we denote by L. So the correct option correct will be third. P equals to mv and L equals to IW. Now for the next question, what is the
जी
relation?
मैम. Yes, yes.
What will be the relation of kinetic energy in both case of linear momentum and angular momentum respectively? So out of this, what will be the answer? Like we know that kinetic energy is half mv square, or we can say it is. I already taught you what was.
Second number, ma'am.
Yes, it will be p square by 2m,
Yes,
and for
ma'am.
the angular, it will be L square by.
Second number.
Correct. Now we have to calculate the degeneracy of a rotation level whose j is 17. So the degeneracy is 17. So what will be the value of j? We know that degeneracy is 2j plus 1. It is given to be 17. So 2j will be 17 minus 1, that is 2j will be 16. Then j will be 16 by 2, that is 8. So the correct answer will be j equals to 8. This was the formula of degeneracy, na 2j plus 1. The answer will be j equals to 8. Now for the next question. Why are homonuclear diatomic molecules like hydrogen, nitrogen, oxygen considered as microwave inactive? They have permanent dipole moment, they lack a permanent dipole moment, exhibit rapid rotation, they have a high moment of inertia. So just tell me what will the condition for a molecule to be microwave active? For a molecule to be a microwave active, we say they should have a permanent dipole moment. So here in case of hydrogen, nitrogen and oxygen, these all are microwave inactive because they do not have a permanent dipole moment. They lack a permanent dipole moment.
Yes, second
Hmm. Correct. Now next question. We have to calculate the reduced mass and moment of inertia of HBr. So for HBr, we have to calculate the reduced mass as well as the moment of inertia, and the length is given to be 147 picometer. And masses are also given, that is mass of H is 1.004 and mass of Br is 79.904 am. So firstly, we know that I is equals to moment of inertia equal to mu r square, and we don't know either I and mu. We only know r. So for calculating I, we should know first the value of reduced mass, and we know reduced mass is equals to the mass of hydrogen into mass of bromine divided by mass of hydrogen plus mass of bromine multiplied by Avogadro number divided by Avogadro number whole square. So we know that mass of hydrogen is 1.004 multiplied by 79.904 divided by 1.004 plus 79.904 into Avogadro number 6.022 10 raised to 23. So what will be the value after solving it? It will be 80.2236 and 80.908 into Avogadro number. So what will the value after this? Dashmi, what will the value? So what will the value after this? The moment of inertia. What to calculate now? So what will the value of reduced mass? It will be 0.1646 into 10 raised to minus 23. It then we convert 1.64 into 10 raised to minus 27 kgs. So this is the value of reduced mass, and we know that I is equals to mu r square. Now we know about mu, that it is 1.64. So just substitute the value of mu here. So I will be 1.64 into 10 raised to minus 27 into r. R was given to be 147 picometer, and 1 picometer is 10 raised to minus 12 meter. So now we have substitute the value. Then after solving it, the moment of inertia will be 3.5 into 10 raised to power minus 47 kg meter square. Is it clear?
जी मैम यस मैम
Now next question. The fifth line in the rotational spectrum comes from the transition between the energy levels and what is the corresponding energy. So we know if they're talking about fifth line, so what will the energy level? We know that the J is in the, we talk about J in the lower state. So if it is a fifth line, we talk about 4 to 5 1. So the energy level will be from 4 to 5. And there's only one option, so answer will be 4 to 5 and 10b. How it is coming to be 10b? How we calculate the energy? We know that the energy is difference between j plus 1 minus ej. So it will be h 2j plus 2. So it will be h, and what is j? J is the lower state, that is 4 plus 2, that is 10. Is it clear? Is it clear? Then moving to last question, second last question. For a heavier isotopic substitution in a diatomic molecule makes the separation between rotational level increases, decreases, either increase or decrease, or same. So what will be the answer? How will be the separation will be affected if we substitute the isotope by some heavier isotope? Like if we substitute hydrogen from deuterium. So what will be the effect of the separation between the rotational energy level? Suppose we have replaced the hydrogen. Suppose we have replaced the hydrogen by deuterium. So we know that for the deuterium, the reduced mass will increase. The reduced mass of deuterium will be more than the reduced mass of hydrogen. And we know that if I is directly proportional to mu by I equal to mu r square, so it is directly proportional. So if reduced mass will increase, then moment of inertia will also increase, and we know that B is inversely proportional to moment of inertia. So if I will increase, then B will decrease. And if we talk about the separation, it is given by BH 2J plus 2. So that means it is directly proportional to B. So therefore the separation between the rotation and energy level will decrease on isotopic substitution. Is it clear? Now next, the rotational energy for diatomic molecule in terms of wave number is, which one will be correct out of these four options?
Decreases.
For the last question, the rotational energy for diatomic molecule in terms of wave number. That will be option C, h by 8 pi square IC upon j plus 1. Option C. So that's also basically in this class we have discussed about. Let me just summarize from this. For linear momentum, it is P, which is equal to mv, and for angular momentum, we denote by L, and L is equals to the cross product of R into P. Or if we just tell about the relation between the moment of inertia as well as the angular momentum, so L is equals to I into omega. And what is omega? Omega is your angular velocity. Now we can also say how we can write this formula. L equals to I omega. Just see, as we know, L is the cross product of R into P. L is the angular momentum, and if you multiply the R into the linear velocity, it gives the angular momentum. The linear momentum into R, it gives the angular momentum, and we know that linear momentum P is mv. So substitute the value of P, that R is mv. So L is mvr. And also we discussed earlier that angular velocity is equal to linear velocity by r. So now substitute the value of v, that is angular velocity into r here. So L will be m into omega r by r. So it will be m omega r square. And we know that moment of inertia is equals to mr square. So from here we deduce the value of angular momentum, that is L is equals to I omega. Then we discuss about the why angular momentum is quantized, that is h cut equals to h upon 2 pi. And then we calculate the value of energy, that energy is h cut whole square divided by 2i jj plus 1, or if we just simplify by h cut, that is h upon 2 pi. So energy will be h square upon 8 pi square I j plus 1. Then we see how is energy inversely proportional to the reduced mass and to the moment of inertia. And then we solve some questions related to the calculation of the energy and the angular velocity. Then the same formula was used for the moment of inertia. We have calculated that I equals to mu r square, and the reduced mass we have calculated. Then we discussed about the rotational constant, how we can calculate the value of rotational constant if we know the first three lines, as we know the separation between two consecutive lines is 2b. So by subtracting these two, we can simply calculate the value of b. Then this relation we have discussed, linear velocity and angular velocity by linear momentum and angular momentum. And just remember that for a molecule to be microwave active, it should have a permanent dipole moment. As in case of diatomic molecules like hydrogen, nitrogen, and oxygen, they lack permanent dipole moment, therefore they are microwave inactive. And how do you know calculate the degeneracy? It is given by the formula 2j plus 1. As 2j, in this question, the degeneracy was given to be 17. So simply by substituting the value of 17, we can calculate the value of the j. Then the same moment of inertia and reduced mass. Then some of the assignment questions we have solved. That's all. Thank you. Do you have any doubts? Sushmita, Rashmi?
जी मैम.
So what is your doubt?
No मैम. It's clear.
It's clear?
Yes मैम, clear.
And to Sushmita? No, ma'am. So what is your doubt, Sushmita? Do you want to repeat some question or like you have a doubt?
No ma'am.
Thank you, ma'am.
Okay ma'am. Thank you ma'am.